As promised, this video is going to look at some of those word problems we see at the end of worksheet 4.5. So the first word problem we're going to look at is problem 4. In this problem we have a triangle. We know that the height of the triangle is 1 foot less than twice the length of its base. That its area is 14 square feet. What we're looking to find out is what are the base and height of this triangle. So in a problem like this, something super important to remember at the outset, how do you calculate the area of a triangle? We're going to use that as the basis for the equation we're going to write. So for a triangle, the area is equal to 1/2 times the base times the height. Okay. I'm going to go ahead and declare a variable for one of those two things. And since the height we see from that first sentence is kind of a confusing thing based on the base, I'm going to actually let the base be that variable. So I'll pick x, and I'll let x be the base of the triangle, and that'll be in feet. Okay, from here I'm going to try and start plugging things into that equation. So I know the area that's given to me in the second sentence. The area is 14 square feet. I'm going to let that 1/2 hang out. I said that the base is x, so I can throw that x in there where the base is. I also have the height is 1 less than twice the base. So 1 less than twice the base, that'll look like 2x twice the base. 1 less, that'll be a -1. And I can plug that in right where I see that height. Okay, from here I just have a polynomial I need to solve. So remember, we're trying to use the zero product property. So the first thing to do is get it equal to 0. So I'm going to move that 14 to the other side. It'll give me 0 equals 1/2 times x times 2x minus 1, and then minus 14. Now, unfortunately for me, right, the second part of zero product is that it needs to be a product. And this is not a product. That minus 14 is messing that up. So we're actually going to have to multiply it out and refactor. So let's leave that 0 hanging out on the left side. And we'll multiply this out. 1/2 x times 2x, that should just be an x squared. Then I'll have a minus 1/2 x minus 14. Now you'll see in this trinomial that b term is a fraction. We haven't dealt with that before. So you're trying to think through, right, something that multiplies to -14 and adds to -1/2. And that's going to open up a whole can of worms with finding fractions and all this other messy stuff. What we can do instead, you might remember from solving linear equations of one variable, when we had all those fractions that we didn't want to deal with, we just multiplied both sides of the equation by a number that would get rid of all those fractions. We can do the same thing with polynomials. So here, if I could multiply both sides by 2, it'll get rid of that 1/2 and won't have any more fractions to deal with. So let's start with the left side. 0 times 2, that's just 0 still. And then on the right side, I want to make sure I multiply all those terms by 2. So I have a 2x squared minus x minus 28. That looks like a polynomial I'm more familiar with, right? Just all integers. So from here, we're going to go forward with that AC method. So I'm looking for something that multiplies to -56 and adds to -1. So we're going to use the pairing +7, -8 for this one. We have 0 equals 2x squared plus 7x minus 8x minus 28. From here, we do that factoring by grouping. So first two, I can pull out an x. So I'll have an x times 2x plus 7. Those second two, I could pull out a -4, which will leave me an x plus 7, 2x plus 7, sorry. And then I can pull that 2x plus 7 out of both of those. So I'll have 0 equals x minus 4 times 2x plus 7. Okay. And now I'm finally in a place where I can use the zero product property. It's equal to 0 and it's a product. So now I'll do x minus 4 is equal to 0, or 2x plus 7 is equal to 0. So solving both of those, on the left I'll get x equals 4, and on the right I'll get x equals -7/2. And always with these word problems, I want to go back and say, do these numbers make sense? So x is the base of the triangle, it's a measurement. So x being 4 makes sense, right? The base of the triangle could be 4 feet. X being -7/2, It's not making a lot of sense. I can't have a negative measurement for length. So I'm just actually going to have this x equals 4. So then my answer is going to be that the base of the triangle is 4 feet, and the height, remember the height is twice the base minus 1, so 2 times 4, that would be 8, 1 less than that would be 7, so the height is 7 feet. All right, the second word problem we're going to look at is problem 6 in section 4.5. So for this problem, Bradley's Bronze has determined that its daily revenue, capital R, for selling S items is modeled by the equation R is equal to S times the quantity 100 minus S. Our question here is how many items must be sold for the revenue to be 900? So remember, revenue is that capital R. So for revenue to be 900, I just want to put that 900 where the R is. So here I'll have 900 is equal to S times the quantity 100 minus S. Okay. So again, 0 product, I want it equal to 0. So I'm going to move that 900 over to the other side. We get 0 equals S times 100 minus S minus 100. Okay, but 0 product, right? The right-hand side needs to be a product. It's not a product, that 900 messed it up. So we're going to have to multiply it out, refactor. Okay, so I'll have the 0, I'll have 100s minus s squared minus 900. So you'll notice with this one, it's actually not in the order we're expecting it to be. So there's 2 ways you can go about that. The first is that you can rearrange it, put it in the order you're expecting, or you can be conscious of the fact, right, that the a is the -1 here on this s squared, the b is the 100, and the c is the -900. The order doesn't matter as much as the exponent on that variable part. I'm going to go ahead and reorganize it, and I'm actually going to go one step further than reorganizing. I'm actually going to move all those terms back to the left-hand side, and I'll show you why in just a second. So let's add that s squared, subtract the 100s, and add the 900, and that'll be equal to 0. Now I did this because you can see now the coefficient on that s squared is +1, right? And it's a little bit easier to do those trinomials where the leading coefficient is 1. That was the whole first part of that video on trinomials. You could definitely do it the other way. You could have left them on the right-hand side, used the -1. Would work out just the same. But to make my life a little easier, I moved them to the other side, get that +1. So from here, I'm just looking for something that multiplies to 900, adds to -100. That'll be -10 and -90 for this one. So I'll have s minus 10 and s minus 90 equals 0. Okay, I have a product, it's equal to 0. I can use the 0 product property. So I get s minus 10 equals 0, or s minus 90 equals 0, which gives me that s is 10 or s is 90. So we go back, context of the problem. Do 10 and 90 both make sense? In this case, they do. We're talking about the number of items to be sold for the revenue to be 900. So they're both positive. I can sell a positive number of items. So we just want to say that Bradley's Bronze must sell 10 or 90 items for its revenue to be $900. Might seem a little silly. You usually think like, oh, selling more things should always get you more revenue. There's maybe some cost things involved that make it, easier to sell either 10 or 90 and nothing in between. Okay, and that'll be it for that problem there.